This is the fourth lesson in Chapter 2. We're looking at families of polynomial functions. It's best to talk about families of polynomial functions at the beginning in terms of their graphs. Looking at the two sets of quadratics, set A and set B, we can define families of polynomial functions by maybe looking at the similarities and the differences between the two sets of graphs. If we look at both sets, we do notice that they share the same x-intercept on both examples. All 6 of these quadratic equations are of the same family. So similarities would be x-intercepts. Differences, well, the vertex changes in all of these examples. And it looks like there's stretches and I guess reflections as well. So the one thing that is constant is the fact that they share the same x-intercepts. There's a definition for this, and it's stated here. A family of functions is a set of functions that have the same characteristics. The characteristics that we're most interested in this particular case is the fact that polynomial functions with the same zeros are said to belong to the same family. Or in short form, if we look back, if they tend to have the same x-intercepts, we would classify them as the same family. The k value out in front may be different, and therefore that's what allows it to stretch or reflect. Let's look at some examples of solving questions involving family of functions. The zeros of a family of quadratic functions are 2 and -3. The important points that we've already picked out is that this is a quadratic function and there are 2 x-intercepts, one at 2 and one at -3. The first question is determine an equation for this family of functions. Because we are dealing with a family of functions, I am going to use a k value out in front and write out what the x-intercepts are in factored form. That's really all I want. This represents a quadratic with x-intercepts at 2 and -3 affected by some k value. But there could be infinite examples of this. So in step B, they actually ask us to write 2. Well, we have a choice. We can put in any number, fraction, decimal that we'd like, and the 2 equations are still of the same family. So you'll notice that the x-intercepts or the factors are exactly the same. The only thing that's different is the k value. Question C is one that we've actually tackled already. It asks us to find the equation of the exact line that passes through the point 1 and 4. And in that particular case, we can use the answer from part A to help us in solving. I'm going to replace 4 wherever I see a y and 1 wherever I see an x. And from here we can simplify. And we find out that k is equal to -1, which then allows us to write out our equation, still in factored form, but representing the family of curve that actually passes through the point 1 and 4. Now, this might be a good time to introduce a next step with this. Sometimes the question will ask you to determine an equation that is what we call simplified. If the question asks you to write the simplified equation, really what they want you to do is expand. So we would take y equals -1 and we would FOIL the two binomials out. X squared plus 3x minus 2. So plus 3x minus 2 gives me a positive x, and then -6. And then the very last step is we would get rid of the brackets entirely and run the negative sign through. And there would be our simplified equation. This time, again, exactly the same question. The difference is it's going to be a cubic equation. So it can have up to 3 x-intercepts, and we see this example it does. So there's no bouncing, there's no flattening out. Because I know it has 3, it has to pass directly through all 3. So once again, part A, determine an equation for this family, y equals k, and then write out your factors. Write two functions. You can replace any value with k. We're going to skip over that question and go right to C. This is the same as before. This time they don't give us a single x and y point, but they do give us the y-intercept, which we know has the coordinate point 0 and -15. Once again, we substitute in -15, and the object here is to solve for k. 0 is a great number to plug in for x because it just clears off all the x's all at once, and now we can multiply this through. We end up with -15 over a +6 is equal to k, which simplifies to be k is equal to -5 over 2. Again, this is a terminating decimal, but try and keep it in the factored form. Because this question did not ask for it in simplified form, I can leave it like this. The final question is sketch this graph. So what we want to do is we want to take a quick snapshot of this and decide kind of where it's going. We have x-intercepts at -2, at +1, and at 3. Because I've written down and I understand that when I multiply this through, I will have a negative leading coefficient, that means to me that I'm going to start high and end low. I also have a y-intercept of -15 way down here. So that works well with my start high, go through this point, and then back down. Make sure when you are doing any sketching or graphing whatsoever, you put x and y coordinate points on, as well as label either the x-intercepts and y-intercepts or label all of the axes. I'm just going to label one just to show, but I would label this 3, 0, and 0, -15, and then for each of the other coordinate points you would label. A little bit more difficult question, but done exactly the same way as this one. This one does ask for simplified. It is a quartic, so there could be up to 4 x-intercepts, and the zeros are plus or minus 1, so there's 2 there, and then we have this, 2 plus or minus √3. So it looks a little bit more confusing, but it really is the same way that we've done most of the questions before. We are going to set up a factored form to start. And we can see that the first two factors are x plus 1 and x minus 1. The next part of this is a little bit tricky. So what we want to do is we're working with 2 plus or minus √3. So one method of making this a little bit more straightforward is to write out the x-intercepts. X equals 2 plus or minus √3. And now that divides into x minus 2 minus √3 equals 0, and x minus 2 plus √3. So notice what we've done, we've just taken the plus or minus, recognize that you can have plus √3 or minus √3, and we've represented them. Here are the factors. Now they look a little bit different than what we're used to, but that's okay. We're going to plug them in anyways. X minus 2 subtract √3 and x minus 2 plus √3. This scrap work over here, I'm just going to clean up a little bit and shrink down. I still like it there because it helps me remember what those x-intercepts are. Moving along, we know we have to simplify this, so we're going to have to multiply these all together. And there's 4 factors here. So the first two are fairly straightforward. X times x is x squared. X times -1 is -x, plus x gives me 0. So positive x plus a negative x gives me 0, and positive 1 times negative 1 is 1. So that's these two factors simplified. Now we get to the next set, and it gets a little confusing. So instead of converting these two decimals and combining it, which we don't want to do, what we do is we think temporarily of the first two x minus 2's as a single term. And this method is called the pseudo technique, and we're going to use this in a number of cases. The pseudo technique. And what the pseudo technique does is it allows you temporarily to substitute in another variable, it's called a, every place that you see an x minus 2. And as you'll see, it makes this question a little bit easier. So wherever there's an x minus 2, I'm replacing it with an a. Now when I FOIL these together, I do get something that looks like this. A times a is a squared. A times root 3 is root 3a minus root 3. Those cancel out. And a root 3 times root 3, remember, is equal to just 3. So the sign is negative, and I have 3. Remember, off to the side here, root 3 is the same thing as 3 to the 1/2. So if I take 3 to the 1/2 and I multiply it by another 3 to the 1/2, the exponent law comes in and says when the bases are the same, you add the exponents. Well, 3 to the 1/2 plus another 1/2, it's a plus sign there, is equal to 3 to the power 1. And that's how we get root 3 times root 3 equals positive 3. Now we've introduced this a, so we also want to get rid of that a eventually. So we are now at some point, and this is the point, where we're going to replace a with the x minus 2. So I'm going to do this in black to show. So a has become x minus 2. This squared is this squared here. Subtract 3. And the remaining x squared minus 1 is still there with that k value out in front. The benefit of using pseudo technique is now we can expand x minus 2. And please be careful doing this. This is a common mistake. Please don't think that x minus 2 is equal to x squared minus 4. There is a middle term there, and that middle term is subtract 4x. And then we have a minus 3. So order of operations, say we have to clean this up before we can multiply it through. And so we have a trinomial of plus 1.